talking about moving to Git and how my team moved to Git. So my name's Tim Moore. You can find me on Twitter at Bitbucket as Timor, and I'm the dev lead for Atlassian OnDemand, which is a hosted set of products that Atlassian provides. And we moved to Git in February of this year, and I'm going to talk a little bit about the process that we used to do that. First, by talking about what our Subversion development workflow looked like before we moved and why we wanted to change it. Then talk about the process that we actually went through to migrate from Subversion to Git without disrupting the whole team and leaving us without the ability to commit for weeks on end, and then talk about what we changed our workflow to after we moved to Git and what some of the benefits of that approach are. So first I'll just briefly go through what our Subversion workflow looked like. And this is going to recap a little bit of what Jonathan already talked about, but with some information about what our team did specifically. So we used to make most of our commits onto trunk in Subversion, and basically we would just keep going along in trunk. And then when we wanted to make a release, we would freeze trunk, we would branch into a stable branch, we would bump the version up in that stable branch, and we would tag that and release from there. And for the most part, this worked okay when things were pretty normal and when there weren't any problems. And we could just keep committing, unfreeze trunk and commit to trunk after that and go along our way. Being a SaaS service, software as a service, we didn't have multiple versions simultaneously in production, so that stable release would generally end at that release, and then we would go on to the next one. And when things went well, this worked fine, but there were a few times when things didn't go so well, and we started having problems with this workflow. The first situation is if you get a broken build on trunk, some bad change goes into trunk. Well, now nobody can commit, you can't release, trunk is completely broken and unstable, and we got ourselves into situations sometimes where we couldn't release for a long time because we're constantly churning through one bug after another on trunk. And another situation that we found ourselves sometimes is there was a critical bug on the stable branch that we needed to fix. And the only thing we could do in that situation, fix the bug on the stable branch, do another release from that stable branch, and then merge that change back to trunk. But this didn't really go all that perfectly. For one thing, sometimes you could run into conflicts. If somebody had made a change on trunk that was incompatible with one of the changes that you made on the stable branch, like refactoring had done or something like that, then you would end up with a bunch of conflicts and you would end up in this kind of a merge hell. And the other thing is that Subversion doesn't actually track multiple parents of a merge. So you see there's kind of a dotted line coming from the stable branch. That's because Subversion doesn't track very well the fact that that merge commit has parents on both trunk and stable. So that meant that if you had to make more changes on stable and merge them back into trunk, you would find yourself back in this merge hell. And the longer you had these branches diverge, as Jonathan mentioned, the more likely it was that you would run into problems when you tried to merge them together. And the more merges you had to do, the more likely it was that something would get screwed up and you'd end up in this merge hell again. We've even had situations where we forgot, like Jonathan mentioned, to take those changes on the stable and merge them forward to trunk. And then all kinds of problems happen. Sometimes we've had dependency versions go backwards from a stable release into the next trunk release. Or there's a lot of problems that you can have. A bug will regress in production because you fixed it unstable and then not merged it forward onto trunk. And so we found ourselves in this sort of constant merge hell. So what does merge hell mean? Well, basically Subversion doesn't deal with merges very well. It doesn't track them very well. It doesn't visualize them very well. So it makes it very difficult with these diverging branches to know what's going on. If you need to merge multiple times from one branch back to trunk, Subversion sort of has merge tracking that it does through properties, but it's not really as good as what Git does. And you can't visualize the way that the branches go apart and come together like you can with some of Git and Mercurial's tools. And some of the clients aren't even compatible with this merge tracking, which means that things could get screwed up, those properties could get erased. You could end up in a situation where you're reversing changes that have been merged by merging them again. We found all kinds of strange situations, and a lot of times we would end up in these conflicted states that we had to resolve manually. And the bigger the conflict was, the more likely it was that somebody was going to make an error when doing that merge back or resolving the conflicts, and we would end up with a trunk that was broken, unreleasable, or had some regressions that were already fixed. So we decided we wanted to do a migration to Git because Git handles these merges better, and also so that we didn't have this constantly unstable trunk situation, that we could work with topic branches without the risk of getting ourselves further and further into this merge hell. So how do we do the migration? Well, basically we want to optimize for stability. You don't want to have your dev team unable to commit. You don't want to have your builds unable to run. You don't want yourself unable to release while you're doing this migration. There's a lot of funny things that can happen during the process of migration, and you can't always plan an exact timeline. So you don't want a situation where you say, we don't have a release for 2 weeks, so we'll do it during these 2 weeks and hope that we're done by the end of it when we do have a release. You really want to make sure that your current process keeps working and you only switch over at the end. That also means that you don't want to change your process while you change your tools at the same time. So Jonathan mentioned this, and I also recommend this. This is what we did on our team. We changed the tools over, got comfortable with Git, then we changed the development workflow afterwards. So the first thing I'd recommend is getting to know Git. So the most important thing to do to optimize for stability is make sure you're comfortable with the tools before you even think about doing the migration. And this means learning to use Git, learning how to do the equivalent things from Subversion in Git. I recommend getting to know Bitbucket and GitHub. There's a lot of open source projects there. It's a good way to learn how to use Git or Mercurial. Check out some projects, maybe make some contributions, send some pull requests. It's a good way to learn the tools. I also recommend the book ProGit, which is a really good introduction to Git. There's a lot of books around. ProGit has the distinction of being a Creative Commons license thing. It's available on the internet. If you just search for ProGit or go to the Git SCM website, they've got the whole thing in HTML there, so you don't even need to buy a copy of the book. You can just read it on the website. I also recommend getting to know Git SVN. So a really good way to learn Git is to start using it on your SVN projects. And Charles is going to talk a little bit more about the details of that in the next talk. So once you're really familiar with the tools, you can start to think about doing the migration itself. So the first thing you need to do is convert your Git repo to SVN. So this is another good reason to get to know Git SVN, is because it can be used to interact with the Subversion repo from Git, but it can also be used to convert your Subversion repo to Git. So we start with a scenario where you've got a Subversion repository and people are committing to the Subversion repository. And you've got a bunch of tools that are reading from it, so you might have continuous integration, code review tools, source code indexing. We had a bunch of tools on our own team. We were using Bamboo, Crucible, Fisheye, Atlassian's tools for source code management against our Subversion repo. So the first thing to do is actually convert that Subversion repo to Git using Git SVN. So I won't get into too many details of how to do that. Charles will talk about it a little bit more. But what you ended up creating is this Git SVN conversion repo. This is going to be a Git repo that is tracking your Subversion repo, and it's going to have converted your tags, it's going to have converted your branches, and that's the first step, is getting that conversion repo in place, and then just manually inspecting it, making sure that it looks the way you want it to do. There's some funny things about transferring from Subversion to Git. For example, in Subversion, there's no real difference between a tag and a branch, other than the convention that you put tags in a tag directory and branches in a branch directory, but within the source control system, they're treated the same way as shallow copies of the trunk. Git is different. A tag is a pointer to a specific commit, so you need to manually clean up your tags. When you use Git SVN, each tag is created as a little one commit branch. What you want to do is probably convert that to annotated tags. Also, branches in Subversion, they can be nested. So that's a problem that we had, is we had private branches under a directory structure. Branches in Git, it's a flat structure, so you might need to do some tweaking to get the names the way that you want. Luckily, with Git, it's really easy to rewrite the repo. You can run scripts on it to filter branch names, things like that. So the first step is to actually get your Git SVN migration repo looking the way that you want it to. Then you want to actually push that to a remote location like Bitbucket, GitHub, or wherever you're planning on serving your Git repo from. You do that. You never want to actually make any changes during this process, any source code changes to your Git SVN migration repo or to your remote repo. If you need to make changes in order to test the migration, you want to do that on a fork. The next thing to do is set up an automatic mirroring process. So you're still having people committing to your Subversion repo at this time, and you're still having tools reading from your Subversion repo at this time, but you want to have something, a cron job or a Subversion post-commit hook, where you can use your CI server to automatically mirror these commits into your git svn conversion repo, and then push those changes to your remote git repo. And this is a process you can set up without having to make any changes in your Subversion workflow at all. So you've just got this read-only replica. And then the process from here, it kind of resembles the way that high availability type structures work, or if you've got like database replication, it's the same idea. You start by replicating the content out to this read-only replica, and then you gradually move your readers over and then your writers over. So the first thing, you move your readers over. So those are the tools that are reading from your Subversion repo. You can reconfigure those to read from your Git repo. So for things like continuous integration, I would recommend start by creating a clone of your existing plan, so that you've still got your main plan that people are watching and that are maybe producing your releases, or still operating off of SVN. But you've got a clone of your plan that's looking at the Git repo, and you want to make sure that they have the same behavior, that they're passing at the same time, they're failing at the same time. Then eventually you can cut that over. Also recommend moving one tool at a time. So start with your CI, and then if you've got a code review system, move that over. Your source code browsing, move that over. Move one tool at a time. Whatever it is that you've got that's reading from Subversion, one at a time, move it over to read from Git instead. Then finally, when all of your readers have moved over to Git, then you can think about migrating people. So in this situation, you've got people committing to Subversion, goes to git svn, gets mirrored automatically to your Git repo, and everything is reading from that. And then when you migrate the people, that's something you have to do all at once. You can't have some people committing to Subversion and some people committing to Git. So you need to put a freeze on the Subversion repo. And you really want to do that when everybody has already committed their outstanding changes. And get everybody to switch all at once. Put your SVN in read-only mode. Open up writes on your Git repo. And then you've got people writing to Git. You've got the tools reading from Git. And you're pretty much done with your Subversion, your Git SVN conversion repo. Although I actually recommend leaving your SVN server in place, just putting it read-only, so that if you have links to it or you miss some tools in the process, you're not breaking everything right there. So you can leave that, just make it read-only, make sure that everybody is writing to your Git repo. So after we changed our tools over and our people over and got comfortable with Git, we changed the workflow that we started to use. So in the new workflow, master, we're not making commits directly on master. Master is our stable branch, and we're releasing directly from master. So when we want to release to production, we tag on master. And then when we want to make a change, we'll create a topic branch, and we'll name that with the issue key, so OD1, that'll be an issue key, and then a short summary of what's on the branch. And I also recommend using the git bash completion here. Long branch names can be very descriptive, hard to type, but if you have bash completion, then it's really easy to type. Just type in the issue key and hit tab. So with all the changes on branches, master is always stable. So the workflow here is somebody makes a change on this branch, maybe somebody makes another change on the branch, and then when the branch is green, it's passed all the testing, it's done all the code reviews, all the QA also happens on this branch where it's isolated, and we're ready to release it to production. Then we do a fast-forward only merge on master. So what does this mean? Well, Git has a few different types of merges that it can do, but a fast-forward merge means that it just advances that branch pointer to the branch that you're merging in without creating a new commit or creating a merge. So this means that this commit has already been built, it's already been tested, we know that it's stable, and we know that it's good to go to master. And then we can do a release from there, advance master, and know that it's already good. And when you've got multiple changes going simultaneously, there's no longer a need to have these long freezes, and there's no longer a risk that somebody on one branch is going to introduce destabilizing changes that are going to screw up somebody else on another branch. And so OD1, the person working on that will be working on their changes, and simultaneously somebody might be adding feature OD2 on a separate branch. And this person can keep working even as master is being merged and released. So this whole thing happens, and this person can, and the person committing to OD2, that branch, can keep committing all masters being released, there's no need to freeze everybody out from committing to the repo. And then once the change has gone on to master, what we do is actually merge that to all of the active topic branches. And this is something you can do in an automated way or a manual way. But basically the idea is that all of the continuous integration is happening on these topic branches. And we can test the merge on that branch while it's still isolated. Make sure that it's good. And then fast forward master to that branch. So that's the workflow that we're using now. And it's something that we couldn't do with Subversion, but we can do now with Git. And that's pretty much all I've got, so thanks.